Okay, so let's test for solder bridges. So a solder bridge is when poor soldering is completed on a device and creates a bridge, which is not good. So I've already tested this and we're good to go. Let's check continuity. Continuity between this ground pin and this ground pin, we're good. Let's check continuity between this lead and this lead. It's obviously good because the light is blinking. Yep, see? So this LED is blinking at that rate because this little board is programmed. This is the device manager test. When I pull the USB out, we should see the device manager react. Yep. And it's reacting. It's showing USB serial device COM9. Okay, test 1, 2, 3. I'm just going to run through this. Excuse me, I'm gonna run through this on the fly. Nothing was prepared, but it's just a proof of concept, okay? So, right now, I'm going to unplug the USB. And if you look at the screen, we see the storage is removed. So I'm going to plug it back in. So I just plugged it back in. Okay, excuse me, I just plugged the USB back in. And we see Circuit Pi. So let's take a look what's inside Circuit Pi. Okay, this code.py is the code that is making this LED flash. So I am going to show the code that is making the LED flash, and I am going to change some settings so you can see the tiny microcontroller, how it reacts to the code. So right now you can't see this because I'm on another screen. I'm going to open up MU Editor. Let me drag it over here. So this is our MU Editor. And we can see our time. So here's our sleep time. This is basically what is shutting the LED on and off. So to prove this, I'm going to change our time here. We can change it to a whole second by just adding a 1 here. Let's pull this back, make it a 0. Pull this, it's going to be a 1. And let's just make it a 1 second on off rate. Save. And as you can see, our our LED light is flashing at a slower rate. So let's make it flash a little bit faster. Now we hit save. And there it goes. It's flashing a hell of a lot faster. Pardon my French. Okay, so for this demonstration, I'm going to putty into this tiny little microcontroller. So we're going to open up our putty. And what is the host? Well, you can find that from the device manager. I see that we're on COM9. So here's where you're going to put serial. That's the connection type. It's going to be COM9. The speed, I believe, off the top of my head, is going to be 11,5200. Open. Okay. And I believe it's Control C. Okay. So we see the LED stopped. So we need to run that script. So we're going to do Control D to reload. Great. There we go. The LED is flashing. And it's also printing out, hello, this is my simple example of Circuit Python. So we saw that in the code. Okay, test 1, 2, 3. Once again, this is on the fly. Okay, so we're going to go ahead and continue Circuit PY, and the board that we're using, the Arduino or Seat Studio, the XIAO SAM-D21. That's this board, and you can see the LED is blinking. It's a simple blink. It's a simple blink program. Okay, and right now I'm going to do some scripting and some programming using Python in a virtual machine using Kali Linux. So I did a video using GPT within a terminal that had background music. It was hard to read the text, so we're going to do it again with some changes, and I'm going to explain what's going on. So let's just open our terminal, and I'm going to have to put the microphone down. So the first thing I'm going to do is make this terminal larger so it's mobile friendly and you can see it. There we go. So I'm going to do the same thing as the video with the music, but I'm going to explain what's going on. The first thing I did was the cat command, cat ai.text. ai.text is the name of a file that I created. You can put anything in that file. You can do the cat command and it's going to read out what's in that file. Props goes out to the Cyber Mentor because that's how I learned how to do all this stuff. And then also props goes out to Eli the computer guy because that's how I learned to do the GPT script. So I believe it's a script. It's definitely a script. It's not programming. The board's being programmed. The script is calling the question. So we're going to read what's in the ai.text file. Okay, it says, welcome to AI. This is chapter 2.1 of my AI experience. So in this video, I want to know the difference between MicroPython and CircuitPython, because we use CircuitPython to configure this tiny little board. So I just want to know the difference. So I already, in the script, I made some changes, and the changes made was the question. Alright, so I'm going to launch the script, and it's going to pull the information from the data set from GPT. Okay, so OpenAI's data set. So let's go ahead and do this. I believe the way we did it was we need to launch the script. So it was Python, not code.py. It was, oh my goodness, there it is. It's micropython.py. This is my naming scheme I made. This is all me, okay? I did not write the code though. So let's go ahead and launch it. Uh-oh. Well, what's going on? We're not in the right directory. So let's do some simple commands. Present working directory. Alright. We'll do ls-la. Alright, this is everything that is in there. That ai.txt is in there, but I need to move to another directory, or another. Linux is a son of a gun, but I need to change directory. Okay, so let's go ahead and do cd change directory, and it's gonna be, oh gosh, what directory was it in? No, Jason, no, why did I put media in there? It's gonna be home. There we go. Home, Kali, desktop, GPT /dubs, enter. Okay, so now we are where we need to be. We can do our ls-la. The -la is to show hidden files. Alright, this is what I need right here. Can't speak. micropython.py. So let's go ahead and launch it. But let's clear our screen. Clear. There we go. So Python, Python, there. Okay, Python, micropython.py. So when I launch this, it's essentially using ChatGPT, and it's going to ask some new questions. So here we go. Question: what is the difference between MicroPython and CircuitPython? Okay, so it's moving a little bit slow today. What's going on here, guys? Alright, so I'm not going to read all this, but I do want to point out, first, let's downsize, make this a little bit smaller. So I got a different output this time, but let's just go based on what Davinci says as opposed to what Turbo says, just for the sake of simplicity. Davinci says MicroPython is a full Python compiler and runtime that runs on the bare metal of microcontrollers. It is designed to be as small and efficient as possible, and is optimized to run on microcontrollers with limited resources. CircuitPython is a fork of MicroPython that is designed to simplify experimentation and education on low-cost microcontrollers. It adds a number of features to MicroPython, such as an easy-to-use API for hardware peripherals and built-in file systems and support for popular development boards. Alright, so there's the difference. Okay, so now let's go ahead and plug along, and I believe in the video I showed the script, how we got this information above that I just read. So to do that, we're going to need an editor. My editor is going to be Mousepad, but I don't want to edit this one. I want to edit the micropython.py just to show you how this works. Boom. Now it's open. Once again, this will be deleted. this API key will be deleted before I even upload this to YouTube. There is the script, okay? This is what launched the answer to my question, which was, what is the difference between MicroPython and CircuitPython? So let's go ahead and close that on out. All right, let's clear our terminal. There we go. So now, once again, we're still working with our little Cduino XIAO SAMD21 board. So we'll take a little look at that, at the code for that. To do that, we're going to have to change our present working directory. I'm not too sure where it was. I could do a locate, but I don't know what I named the file. So let's do this. Change directory. We're going to, it's definitely media, so we'll go media, Kali. Okay, there. Now let's do ls to see what's in there. Yeah, circuit py. So there's our circuit py. So let's go ahead and do this. We'll go / media circuit py. Enter. Now let's do ls. Alright, so there's our file. It's called code.py. And then I'm going to open that with Python. So we'll do Python. Okay. And it's not that file. It's going to be code.py. Uh-oh, what's going on here? Import board, no module. Let's see, what did I do? Oh, I think I remember. We'll go like this. See, I'm not perfect at this. I'm learning too. We'll go / and then code. Uh-oh, I guess I should have practiced this. I don't think this is going to work. Oh, let's go to do a SU. Alright, now let's do ls, make sure, okay. I want to open code.py, so, oh yeah, that's right, we'll do Python. Okay, I don't want to open that, I want to open code.py, so it would be code.py. Oh gosh. Alright, I might have to put this one on pause. Let's go ahead and clear. Jason, you should have prepared. Present working directory. ls. There's our ai.txt. Change directory. Media Kali. Let's go ahead and do that. There's our, do an ls circuit pi. So we'll do / there we go, enter, permission denied. Alright, obviously I screwed this video up, but I'm still going to go on with it. I just want to show you the code. All I was trying to do is launch this code. So that's what happens when you don't practice. So it's very late and I want to go to bed. But once again, here's the script, and this is for our blinking LED. The rate the LED is blinking in this code is 5 times per second, or 5 Hertz. So to prove that this is going to work, I'm going to change the values. Let's just change it to 1 second so we can get this video over with and done. There we go, backspace 1, and then we'll do 0. So this is going to be 1 second. So this LED is going to change when I hit save. There, you can see that the rate that it was blinking has changed. So that tells you that this script, or it's a program. If you think about it, it's firmware within that board. So this is what Python scripting and programming is all about. This is where it's at, okay? They don't teach this in like I'm not even going to say the college, but I have to go to another college to learn this. And everything that I'm doing here was on YouTube. So the only thing I messed up on was opening this code.py. So anyways, we'll end it on that, and I'll watch the video, and I bet you I will never forget my error. But that is just a little bit of insight on the XIAO SAM-D21, this tiny little board that has the firmware in it to make this simple LED blink, and that is just one simple demonstration that it can do. We will get into the, I don't have my glasses on, but it's the ESP8266 board. It's got Wi-Fi. Right now it has a sensor on it, and I'm working with, I believe it's called If Then and That or something like that. It's just another graphical user interface that makes things so much easier for people to program and actually use devices like these on an app, on a mobile device. It's almost error proof, but we'll get into that at another time. And I am out.